Welcome back to the deep dive. Today we're effectively trying to debug the universe. Or well, at least debug how you and I have been taught to look at it for the last 100 years.
Right, it's a pretty massive undertaking.
Yeah, it is. We are digging into a stack of sources that claims we might have been visualizing one of the absolute foundational experiments of modern physics, just totally incorrectly.
It is a really bold claim. I mean, usually when you hear people challenging Einstein or, relativity, you expect to see some incredibly dense abstract equations, but this is completely different.
Yeah, the sources for this deep dive they're fascinating. We are looking at a collection of documents that includes literal Python code for the 3D animation software Blender.
Which is wild on its own.
Totally wild. Plus, we've got transcripts of technical debates between a human user and AI models, specifically Claude and Gemini. And on top of that, a series of philosophical blog posts from a character who calls themselves the Train King.
The Train King. I know it sounds like a villain from a children's book, but I assure you the arguments here are actually quite heavy.
Yeah, they really are. But before we get to the philosophy, we kind of have to start with the crime scene, so to speak. We need to talk about the Michelson-Morley experiment.
Right, 1887. This is the experiment that famously failed. And by failing, it essentially broke classical physics.
Okay, so for everyone listening, Albert Michelson and Edward Morley built a device called an interferometer, right? And the goal was to detect the ether.
Yes. The ether was this invisible substance that everyone back then thought light traveled through. Sort of like how sound needs air to travel.
Right, so just to make sure we're all on the same page, an interferometer takes a beam of light, splits it into two separate beams, sends them down different paths at right angles, and then brings them back together to see if they still match up.
Exactly. And the underlying logic was that as the Earth hurtles through space, this ether wind should sort of push against the light. So the speed of the light should change depending on which direction the beam is pointing.
Like swimming upstream versus swimming across a river?
Precisely. You expect the upstream swimmer to struggle more. They expected to see a shift when the light beams recombined.
Well, but they didn't.
They didn't. The speed of light appeared completely constant no matter which way the Earth was moving.
And that failed result is what led directly to Einstein's special relativity. He basically stepped in and said, okay, there is no ether. Light speed is always constant, period. And to make the math work out for that, space itself must shrink and time must slow down.
That is the textbook version we all learned in school. But our sources today are asking a totally different question. What if the math works, but the visualization, the picture in our heads was wrong?
Meaning, what if we don't actually need all this mystical space warping stuff? What if we just look at the path of light inside a modern 3D game engine?
That's the premise, yeah. The core of this whole deep dive is this piece of Python code written for Blender. It's a simulation script called Zeonat Creates Snapshots.
I love the idea of using a graphics engine to fact-check physics. But I have to ask, is this just some simulation that's rigged to look cool, or is there real hard math under the hood here?
Oh, it's real math. But the key is that it's geometry. It's not relativistic physics formulas.
Right.
Picture a 3D grid in Blender. The z-axis of the vertical line going straight up, that represents time.
So as objects move up the screen, time is passing for them.
Exactly. And in this scene, we have the interferometer moving along the x-axis, flat on the ground. And the user sets the speed to 0.6 c.
Okay, so it's moving horizontally at 60% the speed of light. That is incredibly fast.
Right. Now, the interferometer has two arms. Arm A points forward, straight in the direction of travel. Arm B sticks out sideways, exactly perpendicular to the movement.
Got it.
Light shoots down both arms, hits a mirror at the end of each, and bounces back to the center.
Right, this is the classic textbook setup. And in standard physics, we are explicitly told that without length contraction, without arm, physically squashing down like a pancake in the direction of travel, the light would take different amounts of time to return. The experiment would fail. The math simply wouldn't balance.
Exactly. The standard narrative insists that the forward and back trip should take longer than the sideways trip, unless the forward arm shrinks to compensate. But here is where the code gets really interesting.
Tell me.
The coder sets up this simulation purely using Euclidean geometry. There is no length contraction variable whatsoever, no relativity code. It's literally just the Pythagorean theorem for the sideways arm and the Doppler effect, the concept of a chase for the forward arm.
So he's literally just simulating light chasing a moving mirror. No magic physics variables. And what's the actual result?
The code outputs a variable called T3, which is the final return time.
Hmm.
In the simulation, for both light beams, the one going forward and the one going sideways, T3 equals 25.
Wait, 25 for both, so they tie.
They tie. It's a simultaneous return.
Okay, hold on. This is the absolute crux of the argument, so I want to be super precise here. You're saying this Blender code, which is just running standard basic geometry, no space shrinking, no time warping variables at all, shows both light beams arriving back at the center at the exact same moment.
Yes.
How is that even possible if standard physics says it's impossible without contraction?
Well, that is exactly what the source material explores. And the AI, Claude, actually reviews this code in the transcript and admits, quote, the physics and the code are correct.
Wow.
The user demonstrated that you can get the null result, that famous tie game, purely through the geometry of light chasing a moving mirror and light moving diagonally.
But if the math works perfectly without shrinking the arm, why have we been teaching students for 100 years that the arm must shrink? That feels like a massive oversight. Is the simulation cheating somehow?
It's not cheating at all, but it is highlighting a nuance we usually completely ignore. The code shows that while the final return time is the same, the reflection times are actually different.
Reflection times meaning when the light hits the mirror at the far end of the arm?
Right. In the Blender simulation, the light going sideways hits its mirror at a different moment in time than the light chasing the forward mirror. They are not synchronized at the halfway point.
Oh, okay.
But because of the specific geometry of moving at 0.6 C, the return trips balance out perfectly, and they meet back at the center together at T3 equals 25.
So it's basically a self-correcting delay.
Precisely. It's a geometric balancing act.
Mhm.
But here's the blind spot our sources talk about. The AI acting as the expert in these transcripts, points out something crucial about the vertical velocity of the light. And this is where we have to talk about the map versus the territory.
Yeah, I saw that phrase, the map is not the territory, plastered all over those Train King blog posts. But before we get into the philosophical side, explain the velocity thing. The transcript with Gemini felt like a massive gotcha moment regarding the y-axis.
Okay, let's do the math together. Think about vectors. If the device is moving horizontally at 0.6 c, and we say the total speed of the light photon is always c, let's just call it 1.0 for simplicity.
Okay, 1.0 total speed.
Now, if you trace the path of the light bouncing sideways, it's actually moving diagonally through space, right?
Right, because the mirrors are moving to the right as the light travels, so the light has to angle itself to catch them. Kind of like a quarterback throwing a pass to a running receiver. You have to lead the target.
Exactly. So we know the hypotenuse of that triangle, the total speed limit, is 1.0. We know the horizontal speed of the mirror is 0.6. So using Pythagoras-a squared plus b squared equals c squared, what is the vertical speed?
Okay, doing the mental math. 1 minus 0.6 squared. That's 0.36. So 1 minus 0.36 is 0.64. Square root of that is 0.8.
Correct. So the light is moving at 0.8 c in the purely vertical direction.
Which means it's slowed down.
In that specific vertical direction, yes. To preserve the total speed limit of light at 1.0, the component speed in the transverse direction has to drop to 0.8.
But wait a minute. Textbooks tell us light speed is constant, always. They don't usually add the asterisk that says, hey, light speed is constant. But if you move sideways, it slows down in that specific direction.
That is the primary critique found in these sources.
Mm-hmm.
The MathJack document argues that physics education teaches light speed is c as this blanket statement. They calculate the vector magnitude correctly, but they often fail to explicitly mention that the vertical component slows down.
Right.
And that factor, that 0.8, is actually the inverse of the Lorentz factor, or gamma.
So where we usually see gamma in the dense relativity equations, it's actually just representing this simple geometric slowing.
That's the argument. The source argues that because the physics community of the early 20th century didn't want to deal with that variable velocity component, or maybe they just couldn't visualize it easily, we invented time dilation and length contraction to force the math to look symmetrical.
Okay, I hear that, but isn't time dilation a real proven thing? We have atomic clocks on satellites that literally prove time runs differently up there.
Oh, it is real, absolutely. But the interpretation is what's at stake here. Think about a theoretical light clock. That's a clock that ticks every time a single photon bounces between two mirrors.
Okay.
If that photon is moving vertically at only 0.8 c instead of 1.0 c, simply because of the diagonal path it has to take, what happens to the clock?
Well, it takes longer to bounce. It ticks slower.
Exactly. It ticks at 80% speed. That is time dilation. But notice how we just got there. We didn't say time is magical and warps. We just said the light has a longer path to travel diagonally, so the vertical component drops, so the physical tick takes longer.
Man, that is a subtle but incredibly heavy distinction. It's literally the difference between saying, my clock is ticking slowly because the physical mechanics are lagging, versus my clock is ticking slowly because the fabric of the universe is bending.
Exactly. The source claims we confused a simple geometric reality vectors changing components with a physical warping of space-time. We looked at the map, which is the math, and confused it with the territory, the physical mechanics.
And the sources bring up H.A. Lorentz, the physicist who length contraction is named after. Apparently, he really struggled with this concept.
He did. The Gemini transcript highlights this great historical fact. Michelson, the guy who actually built the machine, originally botched the math completely. He forgot about the diagonal path of the light entirely. He thought it just went straight up and straight down.
Which is a pretty huge rookie mistake. But I guess when you're literally inventing modern physics, you're allowed one or two.
Ooh. Lorentz came in and corrected him. But here's the fascinating part from the source. Lorentz apparently couldn't visualize what the Blender model shows so easily. These 360-degree widely spaced reflection events.
Widely spaced reflection events. Unpack that for me.
Imagine a ring of mirrors, not just two arms. If that ring is moving along and you flash a light from the exact center, the light hits the back mirrors first, then the side mirrors, then finally the front mirrors. In the Blender visualization, because time is the z-axis, this creates a spiral or a tilted ellipse in time.
Oh, I can visualize that perfectly, like a slinky stretching out as it moves forward.
Yes. The source suggests Lorentz just didn't have that 3D mental image. He saw the math not fitting his static view of the ether, so he proposed that the object itself, the physical arm of the interferometer, must literally crunch up to explain the null result. He invented contraction because he couldn't see the full geometry of the light paths in time.
We are essentially using a modern gaming engine to retroactive debug 19th century physics. That is wild.
It really highlights how our tools shape our understanding of reality. Blender forces you to see the geometry. You can't just write an equation on a chalkboard. You have to plot the points in space. And when you do that, the big mystery dissolves into just simple Pythagorean math.
Which leads us directly to the Train King. I have to admit, when I first read the name Train King in the blog post, I expected something eccentric. But it really feels like a dense philosophical manifesto hidden inside a blog about trains.
It is a very powerful metaphor. The Train King represents an observer who isn't trapped in the relative view. He sees the absolute order of things.
Right. The blog describes this specific setup. Imagine a train of length 20 moving rapidly through an electromagnetic field, and we have these EM lighthouses, basically like GPS satellites stationed in the background.
Right. These lighthouses represent the territory, the actual physical electromagnetic field. The train is just a vehicle moving through it.
And the conflict here comes down to simultaneity. This is always the headache-inducing part of relativity. Standard theory says, if I'm standing in the exact center of that train and I flash a light, it hits the front and back walls at the exact same time for me.
Correct. That is the relativity of simultaneity. Einstein says there is no correct order of events. It completely depends on who is looking.
But the Train King says, objection.
He does. The Train King argues that if you look at the lighthouses, the EM field itself, there is absolutely no ambiguity. The train is moving forward, the rear of the train is moving toward the flash of light, the front of the train is moving away from it.
So the light physically must hit the back wall first. It's inescapable.
Physically, within the EM field, yes. The source argues this is an absolute objective fact. The rear-end collision happens before the front-end collision. Period.
So why on earth does Einstein say it's simultaneous?
Because Einstein defined it that way.
Defined? Like, he just made a rule. That sounds pretty convenient.
It does. The source actually quotes Einstein's 1905 paper, where he essentially says, we establish by definition that the time required for light to travel from A to B equals the time from B to A.
He just made it a rule of the game. For the math to work smoothly, we are just going to say these are equal.
Exactly. He assumed the speed of light is isotropic, meaning the exact same in all directions relative to the train. But the Train King argues this is like declaring all lanes on the highway move at the exact same speed just because you want your traffic math to be symmetrical.
Even if the lane going backwards relative to the train is clearly faster because the back wall is literally rushing forward to meet the light.
The source uses a great analogy for this. It says Einstein painted over the absolute asymmetry of the EM field with a mathematical definition. He created a map where everything looks smooth and perfectly relative. But in doing so, he ignored the territory where the physical order of events is totally fixed.
And this brings us right back to that quote from the posts. The map is not the territory.
Alfred Korzybski. It is a fundamental principle in semantics and the philosophy of science. The map, meaning our equations, our theories, is useful, but it is not the physical reality itself.
So special relativity is the map.
Yes, and it's a very, very good map. It works perfectly for GPS satellites. It works for particle accelerators. The math absolutely predicts the right numbers. But the source is arguing that we have confused that map with the territory. We think that just because the math requires time to dilate to balance the equation, that time actually magically dilates.
Whereas the territory, the EM field might just be sitting there doing its basic geometric thing, and we are the ones getting tied up in knots by our own definitions.
The source makes a really sharp distinction between mathematical and physical. They argue that the interferometer physically exists in the EM field. The atoms, the electron clouds, they actually interact with the field.
Okay, so does the source think things physically shrink or not? Because earlier we said the Blender code didn't need any shrinking at all. But now we're talking about atoms interacting with fields.
It's nuanced. The source seems to align more with Lorentz's original physical view than Einstein's geometric warping view. Lorentz thought the actual fields holding the atoms together might deform because of the physical motion through the ether, so the material itself might squash a tiny bit physically. But Einstein took it a step further and said space itself shrinks.
And the Train King is saying, no, space is totally fine, you just have a bad definition problem.
Right. If you accept the EM field as the absolute reference, the lighthouse, then the idea that simultaneity is broken is just a misunderstanding. There is an absolute order. We just can't measure it easily from inside the moving train, so we pretend it doesn't exist.
It's like being in a windowless room on a cruise ship. You can't tell you're moving, so you just assume you're sitting still. But that doesn't mean the ocean stopped existing outside.
Exactly. And the source implies that by denying the ocean, the EM field's absolute frame, we forced ourselves into a corner. We had to invent these parallel universes of time for every single observer just to make sense of our measurements.
This is truly mind-bending because usually when people challenge relativity, they are quickly dismissed as crackpots who just don't understand the complex math. But here, the AI model confirms it. The numbers match. The Blender simulation gets the exact right answer with T3 equals 25.
That is exactly what makes this deep dive so significant. We aren't arguing against the results of the experiments. We are arguing about the story we tell ourselves to explain those results.
The narrative.
Yes, the mainstream physics community says the beams returned together because space shrank. The source says the beams returned together because Pythagoras and Doppler geometry make them balance out perfectly. Both get the exact same return time, but one requires warping the fundamental fabric of the universe, and the other just requires a pocket calculator and a 3D grid.
And Occam's razor, the idea that the simplest explanation is usually the right one, would definitely suggest the explanation that doesn't involve the universe folding in on itself is at least worth a serious look.
It certainly is.
I want to go back to the blind spot in education one last time. The source mentions that modern textbooks explicitly avoid talking about that y-axis slowdown, that 0.8c we calculated earlier. Why is that? Is it a conspiracy?
I wouldn't call it conspiracy. It's more of a pedagogical simplification that eventually just calcified into dogma. If you start teaching college students that light speed components change, you open the door to the idea of an absolute frame, like the EM field. And since the early 20th century, physics has been severely allergic to the idea of an absolute frame or an ether.
Because Michelson, quote-unquote, failed to find it?
Exactly. It's a circular trap. We interpret the 1887 experiment as no ether, so we build a math system relativity that explicitly forbids an ether. Then when someone points out the simple geometry works totally fine with an ether approach, we say, but relativity forbids that.
It's a completely self-sealing logic loop.
And the Blender simulation pierces that loop perfectly. It visualizes the what if. What if we just simulate the photons moving in a fixed grid? And lo and behold, it replicates the Michelson result flawlessly without all the relativity baggage.
You know, the blog post had this funny image of Einstein skipping class or Einstein sabotage. It really paints him as someone who took a mathematical shortcut.
The Einstein sabotage is a recurring theme in those Train King notes. The argument is that by defining away the natural asymmetry, by just saying, let's call it simultaneous, he stopped us from asking deeper physical questions about the structure of the EM field. He gave us a mathematical tool that works, but maybe stopped us from understanding the machine itself.
It reminds me of the menu versus meal quote again. Einstein gave us a perfectly printed, laminated menu, and we've just been eating the menu for 100 years.
Well, the actual meal, the complex, beautiful geometric reality of light moving through fields, just set in the kitchen, completely ignored.
So where does this leave us? Does the user think we should throw out relativity entirely?
No, I really don't think so. The
Yeah.
GPS satellites still need those math corrections to work properly. The map is very accurate. But I think the call to action here is about visualization and interpretation.
It's about not accepting it's weird as an answer.
Precisely. When a student asks, why does time slow down? The standard answer is because the speed of light is constant. This source offers a much better physical answer. It doesn't necessarily slow down magically. It's just that if you move really fast, your internal processes like light bouncing around in your atoms have to traverse much longer diagonal paths. That physically takes longer.
Geometric lag. I really like that term. It feels physical. It feels tangible. It takes the magic out of it, but in a totally good way.
And that matches the Trenking philosophy perfectly. The physical reality of the delay is absolute. The time dilation is just our measurement of that delay.
We really did use a video game engine to challenge H.A. Lorentz today.
We did.
Yeah.
And honestly, if Lorentz had Blender on a laptop in 1890, history might have looked very different. He might have seen that spiral of reflection times and said, oh, it's just the path difference. He might not have ever felt the need to crunch the arm length.
And we might have skipped the whole twin paradox headache entirely.
We just might have.
This has been such a wild ride. From Python code to 19th century ether debates to a literal king ruling over trains.
It really shows that science isn't a finished book. It's a series of drafts. And sometimes, looking at an old draft with a brand new tool like a 3D graphics engine reveals things the original authors completely missed.
So here is the takeaway for you listening. Next time you hear about relativity, time dilation, or spaceships shrinking, try to actually visualize the geometry. Close your eyes and picture the light zigzagging diagonally through space.
Ask yourself, is the territory actually changing, or is it just the map?
And here is a final provocative thought to leave you with, to mull over on your own. If we can define absolute order using the EM field, like the Train King does with his lighthouses, does that mean the relativity of simultaneity, which is the very core of modern physics, is just a definitions game?
As the source says, the map is not the territory and the menu is not the meal.
Chew on that. Thanks for joining us for this deep dive. We'll see you in the next frame of reference.
Goodbye.